Hey everyone, I'm Jayaraki. Today I'm going to walk you through an inferential analysis of a placement dataset. In this video, we are trying to find what affect placements and which factor impacts salaries, and if there are any major trends that we should know about. I have a placement dataset and we are going to do this analysis in Python. First, we are importing the necessary libraries, Pandas, NumPy, Matplotlib, and Seaborn. Then I'm uploading the dataset here using the variable dataset. Next, we are going to check for the null values or missing values because they can really mess up our results. So to find null values, we are using this code dataset dot is null dot sum. This will show us how many null values are there in each of these columns. So we can see that there are two null values in all these columns, and in salary column, we have 69 null values. Let's see what they are about. So here's a little command that I found helpful. Sometimes if our data set is really small, we would like to view the whole data set. So to do that, let's set the option to display dot maximum max rows. Pd.set option display.max rows. This will show us the maximum rows that are in the data set. We can navigate using these two rows. While doing that, I found that there are two empty rows here, and seventh and eighth rows are completely empty. All the cells are none here. So I'm going to drop the two rows using the dot drop code. And in place equal to true here means after dropping the two rows, the dataset is again stored in the same variable name dataset. Next, another thing we found while viewing the dataset is all the students who are not placed, their salary values are left as none. So we're going to replace that with 0 as it makes sense. Students who are not placed, they don't get a salary. So let's replace that with 0 using that filna code. So in the salary column dot filna 0. Again, in place equal to true means after filling it up with 0, we are again storing the dataset in the same variable name as dataset. Okay, now let's start the analysis. How many of them are not placed? To find the students who are not placed, I'm just using the status column. The status column says whether the students are placed or not. So using this code here, I'm just taking the count of the students who are not placed. That is 67 students are not placed. Next question will be why these students are not placed. To analyze it, I'm just analyzing the average academic performance of the students, those who are placed and those who are not placed. And I use this group by code. It grouped the students by their status and their average 10th pass percentage, 12th percentage, degree percentage, and MBA percentage. This dot mean refers the average. So when we get the table column like this, we can compare the average of their academic performances. And what we find is their MBA percentage doesn't vary much. They are nearly the average of the MBA is nearly equal, but their SSC percentages vary significantly. This shows that our academic performance also plays some role. Even the earlier academic performances, it also influences the placement. We are also checking whether it is a gender biased thing, whether the male candidates are placed more, but it doesn't seem so. The placed and not placed count of both the gender, um, it's nearly the same. Okay. Next, what kind of relation between salary and the MBA percentage? And basically what they're asking is if there is a relation between the MBA percentage and the salary they are getting, and which parameter is highly correlated with salary. And so to do that, I'm checking the covariance of the dataset and also the correlation of the dataset. So covariance tells if there is a relationship between the two variables. And the correlation says how strong is the relationship between the two variables. So if we check the covariance of our MBA percentage and the salary, it is positive. So there is a positive relationship between the MBA percentage and salary. And if we check the correlation, it's just 0.13. And a correlation value will be between -1 to +1. A correlation close to +1 is indicates a strong relation. 0.13, it says that there is a relation, but it is not that strongly related with the salary. And the highly correlated parameter is we find at 0.53 is SSC percentage. Again, our 10th pass percentage seems to have some kind of relationship between the salary. Next up is which specialization is getting minimum salary. So not all degrees pay the same. So let's see, we have two specializations here, marketing and HR and marketing and finance. And if we use this bar plot, we can find that marketing and finance is getting maximum salary and marketing and HR is getting a minimum salary. How many of them getting above 5 lakh salary? I just use this query, dataset salary greater than 5 lakh. And if we just take a count, we can see the three persons, and all of them are from marketing and finance. So finance department seems to get paid really well. Now, test the analysis of variance between E and employability test percentage and MBA percentage. Okay, first let's talk about the analysis of variance. Analysis of variance is used to find if the variance between the multiple columns in a data set. And here we are going to find whether the employability test percentage and their MBA percentage or how different they are actually, how different these people have in these percentages. Okay, we get the p-value here after running the code. We are inputting skypay.stats, and after running the code, we get the p-value as 4.67, which is greater than 0.05. They have given the significance level 5%, so we are checking it for 0.05. If our p-value is greater than 0.05, then it indicates that the differences is not much. There's not much difference between their employability percentage and their MBA percentage. Next, test the similarity between the technical degree and the specialization with respect to salary. Okay. Here I'm going to use a t-test. A t-test is used to test the difference, similarity or difference between two columns, two different groups. So here the different groups we are taking are science and tech students and marketing and HR students. Base if we this is just for a practice, but if you actually think about it, uh, science and tech students might also have taken their specialization in marketing and HR. So this is not an entirely independent set. You can't rely on the result of this set, but just for practice, we are doing it here. So after taking the two groups within these two different variable names, Sci and HR, I'm running the t-test and we are getting a value of 0.007. And this is less than our 5% significance level. So, and what this indicates is there is a significant difference in the salary of these two groups. And what does it means in simple terms is the students whose degree is in science and tech, and those students who have done their specialization in marketing and HR, their salaries are different. They are getting different salaries. Their salaries are not in the same range. And they convert the normal distribution to standard normal distribution for salary column. When I first plotted the salary column using the dist plot, I actually got two modes because we have zero salaries there where the students are not placed. So I just removed it and I took the non-zero salaries and then I plotted it. And this is a normal distribution curve. And to convert it into standard normal distribution, we use the code here. What's the difference between the normal distribution and standard normal distribution? The standard normal distribution has the standard deviation like this in -1 to +1, -2 to +2, it kind of shrinks it within a particular range, and their mean is 0. Their average, where the peak lies, is 0. Here it will be somewhere around 3 lakh here. So after converting, we see that the average has become 0 and the deviation is delta accordingly to -1 to +1 and -2 to +2. Next, what is the probability density function of the salary range from 7 lakh to 9 lakh? What probability density function actually tells us is how common or how rare that particular thing is. So according to our question, how common it is to get a high salary range, okay, range between 7 lakh and 9 lakh. And again, I've used this definition here and I've made it kind of like a formula here. So I can use it whenever I wanted. Okay, for our thing, we use the non-zero salaries and 7 lakh, 9 lakh. Starting range is 7 lakh and range is 9 lakh. 5.377 the area is. And from this diagram itself, we can see that it's really rare. Not much students are getting that much high salary. Test the similarity between technical degree with respect to employability test and MBA percentage. Okay, again, we are going to use CT test. We want to find the technical degree students with science and tech. What are all their entrance test percentage and employability test percentage and their MBA test percentage. We want to check if there's a similarity or difference between these two. So again, I'm using the T test. And after running it, we get 5.51. Our p-value is greater than 0.05, which means um, there's no significant difference between the entrance test pass mark and MBA percent. Sorry, it's not entrance test, it's employability test and their MBA percentage. They're getting almost equal salaries. Let's plot any useful graph and explain it. Cat plot is for the categorical data. So here I used it to see whether their work experience really helped them to land in a salary and if it's a high salary or something. So first up, I plotted their work experience against their MBA percentage. And in the next code, I plotted their work experience against their 10th percentage. So you can see we can see here that yes, those who have work experience, they mostly got placed uh, and their MBA, regardless of their MBA percentage. And work experience does help to them. Even if without work experience also, students are getting placed. But when we take a look at their 10th percentage, we can see that in this lower area, students who do not have work experience and who have done poorly in the 10th standard, they were not placed in this lower level. And even if they have work experience and also see we have some they all have work experience, but their average mark 10th mark is very low, and even with the work experience they couldn't land in a job. This graph actually tells us how important it is our earlier academic performance, because all the students who are placed are strictly above these 60 percentage. They're around the 60 percentage here. 60 percentage and above, they have all gotten placed. And you can see some students are there, but most of them got placed around here. So what this tells us is our work experience does helps, but also our academic performances. And this tells us that employers, they usually don't just look at a single factor. They try to look at a combination of factors to make the decision. Okay, all right, let's wrap it up. Let's see what are all the things we have learned from this data set. Our academic performance affects placement chances, and the MBA scores, even the MBA scores doesn't strongly impact salary. Our SSC scores seems to do that, and science and tech students generally earn more than marketing and HR students. I mean, very few students make a salary of over 5 lakh and mainly in finance related roles. Inferential analysis, they helps us to take data-driven decisions. That means colleges can make students go for the financial role as it seems to get paid higher. So that's it for my analysis. I learned something from this. Thank you.